In September 1859, skies around the world erupted in color. Brilliant auroras glowed as far south as the Caribbean, startling people across the globe. Telegraph operators watched in shock as their equipment sparked and papers caught fire on their desks. Fast forward to March 1989. Without warning, 1 million people in Quebec woke up to darkness as a province-wide power grid collapsed, leaving millions in the dark for 12 hours. So what do these events have in common? They were both caused by solar storms, massive eruptions from our sun that can wreak havoc on Earth. Today, we're going to explore what solar storms are, how they can disrupt our modern world, and what might happen if a truly huge solar storm strikes us now. Our sun isn't the calm yellow ball it appears to be from Earth. It's a dynamic, boiling sphere of plasma with a fiery temper. Solar storms occur when the sun releases huge bursts of energy and charged particles. And sometimes this will happen in the form of solar flares, intense flashes of X-ray and ultraviolet radiation. Other times, the sun belches out a billion-ton cloud of electrically charged gas called a coronal mass ejection. These eruptions blast out from sunspots on the sun's surface and send shockwaves through the solar system. If these bursts get aimed towards Earth, they slam into our planet's magnetic field, causing a disturbance known as a geomagnetic storm. When a solar storm strikes Earth, it actually hits us in waves. First, electromagnetic radiation, like the X-rays from a solar flare, arrive at the speed of light, reaching Earth in just 8 minutes. This energy ionizes the upper atmosphere and can trigger immediate impacts. For example, sudden radio blackouts and GPS navigation errors have been observed when intense flares erupt. Next, within tens of minutes to a few hours, a storm of solar energetic particles, mostly protons, will race towards us. These high-speed particles can electrically charge satellites and damage their electronics. Finally, 1 to 3 days after the initial flare, the CME cloud arrives, a massive swarm of charged plasma entwined with magnetic fields. When this hits Earth's magnetic field, it violently shakes it, pumping electrical currents into the ground. And this is the phase that causes the most notorious effects: geomagnetically induced currents in power lines, widespread power outages, and stunning auroras lighting up the sky, far from their usual latitudes. Even mild solar disturbances can create beautiful auroras, the dancing northern and southern lights. In fact, those glowing skies are a visible reminder that Earth is being brushed by charged particles from the sun. Most of these space weather events are harmless and go unnoticed in daily life. But once in a while, the sun unleashes a monster storm, and that's when things can get very interesting for us on Earth. To understand how dangerous solar storms can be, let's revisit that event in 1859. Known as the Carrington Event, it remains the most intense solar storm ever recorded. It's named after British astronomer Richard Carrington, who witnessed an extraordinarily bright flare on the sun on September 1, 1859. Less than a day later, that flare's effects slammed into Earth. Telegraph systems, the high-tech communication network of the time, failed catastrophically. Telegraph lines threw off sparks, operators got electric shocks, and some telegraph offices caught fire. The night sky was so charged with solar energy that people reported auroras so bright that you could read a newspaper at midnight. The auroral glow was seen at places near the equator like Cuba and Haiti, an almost unbelievable occurrence. Now in 1859, society wasn't deeply dependent on electricity. There were no nationwide power grids, no satellites in orbit, no internet. Life went on, and the Carrington Event became a historical oddity. Scientists now warn, though, that if Carrington-level storms struck today, the impacts would be absolutely devastating. A similar solar superstorm in modern times could cause widespread electrical disruptions, long-lasting blackouts, and global communication outages. One analysis estimated that a Carrington-like event hitting us now would cause $2.6 trillion in damage to the United States alone. Around the world, economies could be crippled, and daily life as we know it could be brought to a standstill. So how often do storms like Carrington happen? Thankfully, such extreme events are very rare. Researchers believe a Carrington magnitude storm might occur only about once every 500 years on average. However, slightly less intense but still major storms are more frequent, perhaps every few decades. In fact, a 2020 study of historic data suggested severe geomagnetic storms may even happen more often than we previously thought. So we can't be sure when the next superstorm will hit. Could be next year, could be many decades away, but we do know that the sun will inevitably produce one again in the future. So let's paint a picture of the worst-case scenario. Something like another Carrington event striking Earth in the 21st century. The immediate effects of this might include widespread radio blackouts. Air traffic control, military, and ham radio officers could lose HF radio communications for hours or days, especially on the sunlit side of Earth when the flare hits. Navigation systems that depend on radio signals, like some aircraft navigation or ships at sea, could be thrown off course temporarily. Within hours, satellites at high altitudes might start glitching or failing. Those energetic solar particles can fry satellite electronics and knock out satellite operations. Might see GPS satellites going offline or giving inaccurate readings. Satellite phone networks and TV broadcasts could be interrupted. However, when the CME's magnetic cloud arrives, that's when the hammer really falls. As the Earth's magnetic field grapples with the incoming blast, electrical currents are induced in long, conductive networks on the ground. Power grids are especially vulnerable. Transformers, the workhorses of our electrical distribution, can become saturated and overheat due to these geomagnetically induced currents. In a severe storm, multiple transformers could blow out in quick succession. We'd see massive blackouts across these regions, potentially across entire continents. Unlike a simple outage from a storm on Earth, these outages wouldn't be easy to fix. These could take days or weeks to replace, and they aren't built in large quantities. A truly extreme solar storm could knock out power in many areas and keep it down for weeks or longer, in effect bringing modern civilization to a grinding halt. This no electricity, it won't just mean no lights. Think of everything that runs on power. Communications networks, water treatment plants, fuel pumps, banks and ATMs, hospital equipment. With a prolonged, widespread outage, society would be severely strained. In a striking example, one NASA report pointed out that during such a blackout, even basic services like running water could fail, because most urban water supply systems rely on electric pumps. Internet connectivity could largely go down as well, as data centers lose power, and backup of the generators eventually run out of fuel. Even if parts of the internet infrastructure survive, the loss of power in satellites would mean many of us simply couldn't get online. It is important to note that solar storms do not directly harm people on the ground in terms of radiation or health. Our atmosphere and magnetic field will protect us from that. You won't get a sunburn or radiation sickness from a solar storm while standing outside. The danger is to our technology and infrastructure, not our bodies. But indirectly, however, if our critical systems fail, that will certainly threaten lives. So threat is indirect, but it is still very real. So can we predict a solar storm or prevent any damage? The sun operates on an approximately 11-year cycle of activity, swinging from quiet to stormy. Right now, we are approaching a solar maximum around 2025, which means that the sun is freckled with more sunspots and is more likely to unleash flares and CMEs. Statistically, the risk of a big solar storm increases during solar max. So this doesn't guarantee that a big storm will hit in 2025, but it is a time to be vigilant. The good news is that we're not completely helpless. Space scientists and governments around the world are monitoring the sun 24/7 and improving our ability to forecast space weather. Agencies like the NOAA Space Weather Prediction Center and NASA keep a constant watch on sunspot regions and solar flares, analyzing them daily for any Earth-directed eruptions. Specialized spacecraft such as NASA's Solar Dynamics Observatory and the twin stereo probes stare at the sun and its surroundings, giving us early visuals of any eruptions. We also have satellite sentinels like the ACE and Discover spacecraft stationed around 1 million miles from Earth. These detectors serve as an upstream tripwire, directly sampling the solar wind and any incoming CME. When they suddenly register a surge in solar wind, speed, or a shock wave, we know a solar storm impact is maybe 30 to 60 minutes away, which is often enough time to alert power grid operators and satellite controllers. International cooperation is key. The US, Europe, and other nations already share space weather data. The European Space Agency is planning a dedicated space weather mission called Vigil that will station a satellite at a unique angle to monitor the sun and give us a different viewpoint for early detection. NASA's Parker Solar Probe and ESA's Solar Orbiter are actually venturing close to the sun to study the origins of solar storms right now, which in the long run will improve our ability to forecast these disruptions. Our sun is a life-giving beacon, but it also has a volatile side. Solar storms are a reminder that we Earthlings ride through space at the mercy of our stars' moods. The vast majority of the time, we are bathed in the sun's light and warmth with no ill effects. But every so often, the sun lets loose a colossal burst of energy that can rattle our ultra-connected, electronics-dependent civilization. The potential dangers, from long-term power outages and disrupted communications to satellite losses and navigation failures, sound like the stuff of science fiction, but unfortunately they are quite grounded in scientific fact. The silver lining to solar storms are those magnificent auroras that enchant skywatchers. These northern and southern lights are the beautiful heralds of solar activity. If you ever get a chance to see the aurora, enjoy it. It's a direct, tangible connection to our star's restless energy. And behind the scenes, remember that there are teams of scientists and engineers worldwide working hard to ensure that even when the sun does throw a tantrum, that our modern world will be able to withstand it. With knowledge and preparation, we can face the sun's fury and continue to thrive on our little blue planet and its cosmic shadow. Thank you very much for joining us on this exploration. If you enjoyed this video, be sure to like and subscribe for more videos just like this one every week. Stay safe, stay curious, and keep looking up. Our sun always has a few surprises in store.